So good afternoon and very welcome to our webinar. My name is Henrik Eriksson. I'm the sales manager at Baffin Networks. I'm not the main presenter. Our founder and CEO, Joachim Sundberg, is. And I would also like to thank our marketing manager, Ami Simonsson, for coordinating and managing the change from a physical event to a webinar. That was actually not what we had planned to start with, but you have to adapt to the situation. So we plan to spend about 45 minutes to an hour with you, a little bit depending on the discussions and the Q&A at the end. And the agenda is basically 4 sections. There will be an introduction of our threat protection services. There will be the very anticipated DDoS attack demonstration. And then we're also going to cover threat intelligence for a bit and look at our threat insight service. So this presentation will be recorded and made available after the session. So if you follow us, Baffin Networks, on LinkedIn, you will be able to see when we post a link leading to the recording. We plan to have a Q&A at the end, but if you have any questions, you can use the Q&A button. And as soon as you have a thought or a comment or something you want to ask, put it in there, and then we can make sure to cover it at the end. So I will soon hand off to Joachim, but I would like to highlight a promotion that we just launched today. Because of all the actions taken to limit the consequences of the coronavirus, we see that a lot of companies are now prioritizing their teams. And people work from home, and maybe some security projects will be delayed and some actions cannot be taken as quickly as they wanted. So therefore we want to extend an offer to all companies and organizations to protect their internet-facing services free of charge for at least 90 days or as long as needed until we have this in some kind of control. And since our service is really easy and fast to activate, we can do that within a day. So don't hesitate to contact us or tell somebody you think could use this type of service. So with that, I would like to hand over to Joachim.
Thank you. I hope everyone here hears me clear. So I'm going to walk you through what we do here at Baffin Bay, as well as show you some typical attacks that occurs on a daily basis, and how our customers works with the portal to interact with the information given around attacks, be able to track and follow, and also do analysis based on activities that occurs, not necessarily only related to attacks, but other things as well. So with that, I'm going to start off with an overview of what we do as a company. So Baffin Networks is a cloud-based cybersecurity company, and we really deliver 2 types of services. One called threat protection, which is a real-time threat protection service for our customers, where we protect customers' assets facing internet. So it has to be an internet-facing asset. It can be web server, it could be mail server, FTP, or API, or something else that are accessible through the internet. We do that through a number of different functions, but the important part here is that we do it through what we refer to as a single pass platform. And a single pass platform for us is a platform that can, first of all, deal with all sorts of attack. So there's no like master scrubbing center that we route traffic to. So they're all equipped with the same capabilities. Secondly, in a single pass platform, you should not necessarily need to decode and normalize a packet more than once. And then instead, just pass around the pointer to allow people to inspect the traffic. Think about it as you open an envelope and you open it once and you pass around the letter within the envelope to everyone around the table before maybe closing the envelope again with the letter inside and pass it on to someone else. And that's the same when it comes to be able to work with security related attacks but also other things from a DPI perspective. We bundle our capabilities into different modules, as we call them, where everyone comes on board on a flexible monthly subscription, really no ties into years or 2 years or 3-year contract, rather on a month-to-month basis. We've done this because we haven't had any customer left our platform for the last 2 years and 4 months, something we're really proud of. But also it allows us to create that flexibility and remove that hurdle or step to actually get on board and start using the service. On top of that monthly subscription, we have DDoS protection layer 3 to layer 7 for everyone, threat intelligence, and traffic analysis for everyone. On top of that, customers can select to use bot protection, web application firewall, intrusion prevention, and application performance functionality. But those are not necessarily tied to the base bundle. Those are individually selected on a per customer basis. And you don't need to turn it on for everything. You can turn it on for specific services that you want to protect with, for example, a web application firewall. The second type of service we run is what we refer to as threat intelligence or threat insight. And threat intelligence is highly important when it comes to deal with cyber threats today. So knowing everything or knowing as much as you can about the different type of attacks, as well as the devices and IPs that attacks you, allows you to better understand the threats that you're facing, and that therefore also better capable of dealing with mitigation, both detection as well as mitigation. Today, threat intelligence or threat insight is a free-to-use service. I'm going to come back to that later on, later in the presentation, but it's a free-to-use service that anyone can use. Just browse buffinbaynetworks.com and you will be able to search IPs on the internet. And we actually have all IPs in our database with activities that they performed over the last 3 years. So if they have been infected by malware or what we refer to as a weapon, we have seen it on our global sensor network throughout the last 3 years. So that's a really good way of actually getting insight into what IP addresses are doing. So looking at the different module in the threat protection service that we offer customers. On the previous slide, I showed you each module individually. Now the same sort of picture is a funnel instead. And reason we describe this as a funnel is because each capability or each function or module peels off another layer of the onion until you get into the core and can actually do the heavy lifting, inspecting, and then pass traffic on. So looking at the first layer of defense in our platform is threat intelligence based on source IPs. So IPs that we already know are bad. And on top of that, we have DDoS protection. And DDoS protection is layer 3 up to layer 7. So it allows us to identify whatever threat intel is not picking up and blocking based on algorithms that we use and the flow analysis, behavior analysis, machine learning capabilities. Once we detect something and determine that this is an attack and it's not efficient to continue monitoring this flow, we actually push that flow down into threat intel categories. And we have a category called active bad actors, which is a category that activates once we have a DDoS attack been identified and occur, and we start to push patterns based on that attack into that category and start to block it in hardware instead. Also, what that top layer is doing is taking care of TCP optimization, compression against the client, and so on. And that really peels off the majority of the traffic and the bulk traffic that customers could expect to get. And then after that, we start to look at more compute-heavy things like bot protection, looking at behaviors from HTTP perspective, for example, making sure that whatever connects to your APIs or your website, either dynamic or static, is being validated, tested, vetted to make sure it's a legit behavior. If it's not, we will enforce blocking on that browser. And we can do that based on single browsers. So for example, if you have a Chrome and a Firefox browser on the same PC, you start to script something in your Chrome browser, we can actually narrow it down to that specific Chrome browser and block traffic for that device or that browser application. And then the next layer on below that is the web application firewall, which looks at traffic from a vulnerability perspective into your web applications. And once we've gone through that layer, we get into the DPI capabilities or intrusion detection prevention capabilities, where we look at vulnerabilities against operating systems, known applications, and protocol abuse on an application level, which is obviously outside HTTP traffic at that point. And then once that validation has been done and packet has cleared all the different functions, we send traffic off to customers' assets that we protect. But before doing that, we can also apply additional application performance capabilities like multiplexing, compression. We can do load balancing towards the backend servers and so on. So really a funnel model here allows us to use the best function at the best place to actually detect as well as mitigate the attack, making sure that we use and leverage the resources we have in our platform in the best way. So another important thing, I mean, you heard me talking about the different modules and different things that we do, but for us, it's really important that you are in control of your assets. You understand what happens and what goes on. And we built a really comprehensive portal around this that allows you to self-manage your configuration. Or you can, if you want to, rely on the SOC, our security operation, to do that together with the platform itself, which is obviously self-learning. But if you want to dig into what actually goes on, be part of the configuration, you have that option as well. So everything we do is visualized. There's no black box capabilities. We try to give away as much as possible. Your data is your data, and whatever we generate around that should be given to you, so you can actually investigate as well as verify that we actually done the right thing in terms of blocking. I'm going to come back to that when I do the demo. Today we have a global presence, like we should. We have currently 8 sites. 7 sites of those are what we refer to as threat protection centers. And the threat protection center for us is where we clean the traffic for the customers. So see a threat protection center as a big washing machine, taking in customers' traffic at that location, clean it off and send it back to the customer. We do that through either BGP or through DNS. So bigger customers with their own BGP configuration, their own public /24 or several /24s can announce their networks into us, and we will announce the networks out to the internet and attract traffic into us through that way. For smaller customers or services that maybe operate within a cloud provider like AWS or Google Cloud or Azure or somewhere else, DNS is the most preferable way to get traffic into us, meaning that you configure and set up the service in the portal I showed you on the previous slide. Once that's complete, you update your DNS record for that www.something or API.something to point to the new IP that you just created in the portal. And then traffic gets into us and we can clean it and send it back to whatever service is behind. So from those few slides, I think there is a number of takeaways here. We are cloud-based and we do both threat protection as well as threat intelligence. And I think the power of that is highly important, and we're going to show that later on as well. But it's highly important. There's no hardware requirements, so you don't need to install anything on-prem. Everything is done from the cloud, and it's a service that you turn on and off within 5 minutes. Also the flexible subscription model that we have allows you to start using the service really quick, as well as opting out from the service if you don't like the service that you get. And I think the layered security approach is again important to highlight. That's how we in the industry, and that's how the industry as well achieves the best security. Security is all about layering capabilities, making sure that the right function deals with the right set of attack vectors. It's like you don't want to have an IPS dealing with WAF issues. And you don't want to have a WAF dealing with IPS issues. So the right function at the right place is highly important. The problem historically has been that that's usually been siloed capabilities, siloed products that inspected a packet, didn't have any understanding of if a WAF have seen it before, or even if there is a better way of mitigating that attack that's been detected by that function in a different function. So that nerve network, that communication between the different functionalities is highly important. And I think that we are not the black box, that we are a solution, a product that you can use, and it feels like it's your own product in your data center, where you can log on the portal, you can do the configuration, you can see what happens, and so on. It is important as well. And obviously, you wouldn't go and shop a service like this unless this has a global coverage. And in our case, we direct connected with all the big cloud providers like AWS, Google Cloud, and so on. Allows for really high speed, low latency. Availability and performance is equally important as security in this case. So with that, I'm going to try to see if we can get the demo going. This is actually going to be a demo in real time, so bear with me. I guess the demo ghost is going to pop up as well somewhere and put stop this things. So I'm going to stop sharing that screen. I'm instead going to go sharing. I'm still going to go sharing another screen. Can Henrik confirm that you see the dashboard? Or Amy?
Yes, we can see the dashboard.
Nice. So, so right now you're looking at the view, which is the dashboard view of our portal. So here you do the configuration, and in this case here I've set up two demo sites, one called DWAP and one called Use Shop. They both OWASP oneable sites that can be used to play around and learn how to hack and do SQL injections and cross-site scripting stuff and other things. But also they are an endpoint, so you obviously can throw a DDoS attack at them if you want to. And these devices are configured behind us. So we have a front-end IP. That's the IP I refer to as an IP you put into your DNS server. And you have a backend IP, which is the original IP of that server. This particular IP here belongs to a device in DigitalOcean. So it sits in DigitalOcean. And here you can see I've turned on different functionality, both application as well as network DDoS. I've done some multiplexing as well as setting all the cookies to HTTP only. This specific service is an HTTP service. That's typically not what you would have as a website. You would probably have SSL attached to it. And obviously we do support SSL as well. So creating a service would be preferable with HTTPS or HTTP2 TLS certificates or keys as an example. And then you go and do configuration of the different threat intel, the different categories that we categorized for you. So this is based on IP addresses. And then also bot protection, web application firewalling. If you have intrusion detection license, you would get that as well as blocking different regions where traffic may originate from, where you don't want to see that traffic. So I'm going to close that down, and you can see that this IP 185.195.93.25, you can verify it's correct by typing it into your browser. You would get an HTTP basic auth page. That basic auth page requires a username and password to log on to the service. that's not the point here. We're still going to do the attack. So let me see. We're going to start off with a simple thing. So demo 1 or demo 2. For example, things you may see in your logs when you view web server is things like .pvd, for example, or .env. These are very, very common Unix type of access to files. So things that you hide on the web server from a file perspective that can reveal things. For example, username and password. So in this case, this is an environment variable file that if a developer would have left that in the repository that you sync to the web server, may actually have come with it. And that could actually reveal information about the web application that you don't necessarily want to reveal. So the point here is that we look and inspect all traffic that goes towards this website. If we find something which is wrong, can either be an SQL injection, cross-site scripting attempt, or a parameter that's not allowed, cookie values, header values, or in this case, a URI, we go and block that page. So all pages that gets blocked is associated with what we refer to as an incident ID. An incident ID allows you to track back that specific block that we did. So again, going back to the portal and looking at the dashboard and going to what we refer to as an attack view, you would actually see that attack showing up in here. So here's my Unix hidden.access file that I tried to access. And as you can see, we also reveal all the information related to payload for that specific attack. So it was a GET request on the .env resource that got blocked with all the user agent information. You can see the cookie that we actually set. So TPC persistent cookie is a persistent cookie that we set for HTTP traffic as default. The point here is that I can also click on Threat Insight and get additional information about this IP. So as you can see here, the IP I came from when I did this was a Telia company IP. We can see that it's been doing port scans against one of our sensors. And obviously that was me doing a port scan against the sensor that we operate globally. We can also see related IPs within that network that actually has issues. So that's a very simple way of viewing the attacks. We can also see that there is, in a similar way, there is a bot defense activity that has occurred. And that's us verifying that the browser I was connecting with to the resource is a valid browser. In this case here, it was only logging that activity. So it's a verification that happens in the background from our bot protection module. That verifies that the browser I connect with is a valid browser and the activity I do is legit activities. So that's a way that we visualize and allow you to actually see everything that occurs. So let me now jump to. I'm gonna start off an attack. Let me. So I'm now sharing a terminal, and that terminal is going to use cluster SSH to connect to 10 different IPs, and that would open up 10 different windows. And hopefully you now see, you're going to see them align. At this point here, you should be able to see 10 different windows, and I'm gonna start attack, which is HTTP flood push attack that happens. I'm targeting the same endpoint, the demo2.buffin.online website. So now pushing about 1.5 to 2 gigabit per second, which is a very, very common size type of attack. And we're going to go back to the portal again, and we're going to look and see what the portal now says. So I'm going to update view here. So right now you can see traffic was going from a few. It was actually that small amount of traffic to the website that it wasn't even noticeable in this case. But now we can see it ramping up and approaching 40 megabit per second. It's going to continue to go up before it goes down again. You can also see that I mentioned it before. When we identify DDoS attack or bad traffic, we continue mitigating that for a certain amount of time until we recognize that, okay, this is just continuously DDoSing and this IP is continuously DDoSing. So there's no reason for us to recalculate that value. We know that that IP is bad. It's nothing else that comes from that IP that has been good. So at that point, we're pushing down the IP, the source IP, into what we refer to as threat intelligence and a specific category called active bad actors. And active bad actors allows us, that category in threat intelligence allows us to block traffic in FPGAs. So instead of actually trying to do the calculation, figure out what goes on and so on, now the IP is pushed in and validated just based on the IP header, saying that, okay, we have an active ongoing DDoS attack from this IP or these IPs, continue blocking those on layer 3. So that becomes a more efficient way for us to actually deal with the traffic. That gives us the capability of actually scaling much higher, which is obviously one of the reasons with a cloud platform like this, that you want to make sure you can put many customers behind one service. So again, I'm gonna update that. You can see it now. It actually went up to a gig of traffic, and you can see that we continue blocking that in the threat intel list or category. We figure out really early on that this is DDoS traffic, and now just continue blocking package by packet in the DDoS in the threat intel category. At this point, I actually turned it off, so now you can see it went down again. So we were running that attack for about the average time. So from 16:27:30 to 16:30:30. It's about 2 minutes, 2.5 minutes approximately. During the ramp up time and ramp down. And that's usually the most common amount of time a DDoS attack is running against an organization today. And also size-wise, this is a very, very common size of a DDoS attack. This would take down most organizations. It's above 1 gigabit per second. It would take down most enterprises today. So if you are a bank connected with 500 megabit per second, this would be twice as much as you actually can handle. And traffic, you will start to experience issues on the web servers. So let's have a look at this and see what went on. So first of all, let's take a look at network visualization. So we can see I'm scaling down to the deepest view from a flow perspective. As you can see, traffic is only originating from the DDoS source here. All that traffic came from DigitalOcean in this case. We can see the traffic was targeting, the 100% of the traffic was targeting port 80. We had a few packages, I would guess, on port 50075. All traffic came from Amsterdam in this case. If I would expand this view and set it to the last 12 hours, I would see that traffic originates from other places as well, but still the majority of the traffic to the website came from DigitalOcean. I would also get some more additional ports traffic tried to enter to, as well as countries traffic originated from. So jumping over to the attack view and take a look at this. I'm gonna now filter it down again to the last 5 minutes to remove some of the events. We can see that the attack event that occurred was threat intelligence, and that all traffic except one packet, I believe, was put into the active bad actors. So that's traffic originated from my IPs. If I would click on one of those IPs, I would see that this is a Gatecare 1 let me pick another one here that I know. Take this one. The ISP that DigitalOcean uses is different from different instances, but here it clearly show you DigitalOcean AS number or owner of the AS. This IP has not done anything else on the internet. So this is how I see if this IP has been part of other type of attacks that hit other devices on the internet. But as you can see, there's nothing here. And reason for that is because I just set up these devices and they haven't been involved in other type of attacks, which makes them clean. So there is no category that they already existed in from a threat intelligence perspective. In this case, we created a category dynamically for them, which is part of what the platform does. So based on traffic it sees, it created the active bad actor category. So let me see. I'm gonna scale this out and set it to the last 12 hours here. Other things you can do is search on things. So if you have a certain IP that you're interested of knowing more of, you can actually browse that or search that or filter that through the search function. So not only removing specific type of attacks, but you can also search using the search field. We can also see that we have traffic from or HTTP traffic from a non-browser or browser compliant source. This is being picked up by the web application firewall, the same function or module that picked up the .env attack or access to a hidden Unix file. So that also occurred. And I think the good thing here and the point around how we do correlation and aggregation of data or events that occurs is that if you would use a SIEM solution or if you would use a firewall view, you would see all the different attacks that occurred in one table. You would have hard time to sort out, okay, were these specific devices or IPs related to the DDoS attack or were they related to something else? And also, if a DDoS attack occur and you at the same time get a .env attack, that would actually clearly show out here and saying that, okay, that was not an event related to threat intel. That's an event related to a web application attack. So the sorting and filtering and aggregation of data allows you to find that needle in the haystack and not miss maybe the attack that actually would cause you more issues than others. Cool. So I'm gonna go back to the presentation. I'm going to walk you through a small diagram. We've done the demo of the attack and how we visualize and what you see. We looked at the configuration. I think this picture gives you sort of an insight into how traffic attracts into us. On the left-hand side, you have legit users as well as attackers. I was one of the attackers that did a HPing, which was a push flood DDoS attack up to a gig, just above a gig, as well as the .env attack. You may have been the good user that actually tried to access the website in a normal way. We attract traffic in through the router setup or the proxy setup. Once it goes into our TPCs or threat protection centers, we clean it here in the core, and then we send it back to the customers. And that can be done over NAT or network address translation, where we send it to public IP on your side, or it can be done over GRE if the customer is a routed customer setup. We also have the capabilities and interact with, for example, FortiDDoS if a customer has on-prem equipment, where they can signal into us and say, hey, this is too big of an attack for me to handle. Can you please deal with it? And then we can start announce the network and attract traffic into us. So the next part of the presentation and the demo is the power of threat intelligence. We spoke about it earlier. We have the threat protection service and we have the threat intelligence, or what we refer to as threat insight. So my belief is that the more you know about the source IP, or the more you know about what actually are a threat for you, the better you are capable of actually protect against it. First of all, identify it, and secondly, protect against it. Attacks don't happen by themselves. Either someone willingly do them in the way I did today, or they are automated, but they still don't happen by themselves. It's still something there that actually does it or performs the attack. So how do you tell a friend from a foe in this case? Knowing who fires the weapon allows you to better protect yourself. And I think I've gone through that a number of times. The more you know about who actually holds the weapon in a crowd of people, the more likely you are going to be more safe if something happens. Today, 40% of the web traffic is generated by bots, but not all bots are evil. We do have bots like Pingdom and others that checks, for example, website uptimes, and those bots are good. So those bots you want to let through. So you want to make sure you can differentiate between a good bot and a bad bot. Not all scanners are evil. Some scanners are really good, or doesn't cause you a problem. So you don't necessarily want to block those. A device becomes a bot after it's been infected by a malware. We refer to that malware as a weapon. So knowing the different weapons, knowing the different malwares and where they are and who is infected by them allows us to protect our customers better. And also there is different bots. So in other words, different type of weapons for different type of attacks. Like in the real world with weapons, it's different type of weapons for different type of missions that you as a soldier would be on. So we have something called Threat Insight, and Threat Insight is our lexicon or atlas into all the IPs on the internet. So I'm going to take you to that view. So here you can see our website, and if you click on Threat Insight will give you top widgets in terms of suspicious IPs that we track, as well as suspicious countries and AS organizations. I'm going to pick the first one here, which has a highly high or slightly high number of hits to our sensor network. So I'm going to click on that, and it's going to reveal for me where this IP comes from. So you can see India, that's where it originates from a provider or owner called Nirab. And you can also see that we display the AS number, the parent prefix of that, if the IP address is blocked in our blacklist or not. And we qualify IPs to enter into blacklist if they have an AI score or activity indicator score on 80 or above. So you can see here, this one has 100, classified as high. So it allows me to click on the graph and render the activity of that IP address on the internet over, in this case, the last week, but also over the 3 last months. So this maybe is a better view. We can see that this IP has been active and infected by a malware or a weapon, and it has actually hit our sensor network globally. And we can see that the activity indicator of this IP has been quite high for a long time. It dropped down to 25, sometimes to 0, most likely because it's been turned off for a few days, and then turned on again, and then become active, and then been used in attacks as well, or had different type of schedules or tasks that it performed. So these are devices that are maybe home user devices or IoT devices. The point here is that the owner of that device doesn't know that these things are occurring. So going back one step to this view again, we can see that this device has done port scans on 135 of our sensors on the internet, and about 5.6 million, 5.7 million packages been generated on different type of ports. We can also look at the same type of graph from a hit perspective when it hit our sensor network, so you can get a feeling of if it was active active, but still generated a few packages now, or if it's been that over a longer time period. We can also see that this device also uploaded malware into one of our sensors. So our sensors are really vulnerable machines that we want to be attacked because it allows us to get that insight into how does attack looks like, what kind of malwares are spreading, and what new malwares are popping up. And again, those malwares are weapons for us, and understanding who actually are infected by those and who spread those allows us to better mitigate as well. And we can also see that these are the other devices within the network that actually are infected. So we use, jumping back to the presentation, so we use that data to both enrich the portal. And you saw that previously when I did attack and we clicked on the arrow or threat insight arrow after the source IP, you get to see the same sort of view. And that allows you to understand if the attack was targeted or if it's hitting everyone out there. And when I showed you the DigitalOcean IP I was attacking from, or one of the IPs I was attacking from, you could see that I had no hits on our sensor network. So you could assume that that was a pretty targeted attack. And that was pretty correct, because the only thing this IP or these IPs in the attack is going to do is attack that website I just attacked. And after that, it's going to be turned off. The device is going to be turned off and disappear. So in this case here, I know that this attack was targeted using that data or enrichment of the event using that data. Also, it allows us to have those categories in the systems and allow you as a customer to go in and turn on and off different categories and say that, hey, I'm not going to allow traffic from scanners, from anyone that uploaded malware or are infected or been part of a DDoS attack before. So you can go and quickly select those categories and we will automatically enforce blocking based on source IP at that point. So insight is power, and I've spoken about it quite a lot. This is another example. So in this case here, this would be a normal view within your weblog. So if you operate a web server on the internet today, this would be a very, very common view. You would see a source IP. You would see a URI that's tried to be accessed. You would see the user agent. In this case here, we can see that is something strange going on. So we see the source IP, we see the URI, which is not a common URI for my web application. It looks like it's a shell command. It tries to get access to the shell. It tries to do vget from a resource to pull down something and change the do a change mod on that file for execution, so the program can actually run and then execute the program. So if we break this down, this is the IP here is what we refer to as a scanner, and the HTTP command in the URI, or HTTP resource in the command or URI, is what we refer to as a loader. And the last part of the URI for that resource, the ARM7, that's the malware. The naming here can be anything. If you look in your logs, you're going to see maybe different names. In the end of the day, it really doesn't matter. That's just an endpoint name. What matters is the malware that actually gets downloaded when you go to that URI or that resource. So what I did here, just before this, looked at something really fresh and pulled out from the weblog. I did a search in our database, in our weapons database, and search for the IP address that shows up in the URI. And out of that, I got a list of different fingerprints and resources or URIs and when they were discovered. So as you can see here, this is a malware that was discovered on the 17th of February. So relatively fresh. And we have seen it with different type of resources or endpoints. And in this case here, it also carried different type of fingerprints. So this fingerprint is unique for the malware or unique for the weapon. You can see that the same fingerprint occurs twice. So we have 055 here, we have 055 here, but you have two different names or URLs, one called TN and one called UC. So taking this data and having this understanding and looking at, okay, what else does other people know about this data? So I took the fingerprint, I searched for it, or actually I took the URI, and I searched for it in VirusTotal. And we do that, we do cross-correlation of our data from different resources to understand how widely spread is this, how widely known is this specific malware or weapon. And as you can see, there were 10 engines out of 72 engines in VirusTotal, and VirusTotal represent all the big major AV or anti-malware vendors today. There were 10 engines out of 72 that actually did detection of this URI or URL. In the same way, I took the fingerprint and got a similar result. So it shows that you can actually go and search on the URL, but you can also search on the fingerprint of the actual malware that actually gets downloaded. And I think that the importance here is that having this understanding and knowledge where it spreads and where it spreads from allows us to understand, okay, who are the bad guys in the crowd of people that actually we need to protect ourselves against. Put on an arm's length distance, make sure they don't enter into the website and can't continue doing bad stuff. That's how you can actually make sure that you block something on a really, really early stage in the process, rather than using the last resource that you have to identify and block the traffic. I've done demos of the threat intel part already. We looked at the UI, and this is again free to use. So feel free to use it, share it with colleagues and others, and cross-correlate data from here with data you see in your logs. We also have a resource available on support.buffinbaynetworks.com where you actually can go and download threat feeds. These are updated on a daily basis. So if you're running a firewall that accepts comma-separated files or JSON files, or if you run a F5 networks load balancer, you can actually download daily files where we actually list the IPs that are bad, that we block on. And you can start blocking them directly on your firewall or in your perimeter defense. So with that, I'm going to open up for questions and answers. You're more than welcome to write in the chat, I assume. And I think I'm going to give back voice to Amy, who can lead that discussion.
So like Henrik said, you're more than welcome to contact us afterwards on either social channels or on our website. And that is if you have any questions at all, or if you want to use the 90 days of free protection for your application or website.
Thank you.
Thank you very much.